In this video, we're going to provide a brief introduction to the use of pivot tables in Microsoft Excel for summarizing categorical data. This is a powerful tool that will not only be useful on Lab 1, but on your final course projects and possibly beyond in other courses or real-world applications which you might encounter. So we have before us a spreadsheet of data. It's sort of spread out in the typical form. Each column represents a separate variable. Each row is a different observation or respondent in the survey. This particular data set came from Math 37 students in spring 2015. And today we're going to focus in this video on investigating the relationship between risk level, which is classified as a low risk taker or high risk taker, and the primary major of the student, which is classified either as engineering, computer science, business, natural science, social science, or humanities. So to create a pivot table and summarize these variables, we first highlight all the relevant columns in our spreadsheet. We then go to Insert Pivot Table, and after clicking on OK, you see a new sheet pop up in your spreadsheet. Now, I should mention that I'm using Office 2013 on a PC. If you are using a different version of Office, these steps might be slightly different, but hopefully somewhat similar. So we have a blank pivot table here, and the way to fill in the pivot table is to use these pivot table fields on the right. So what we're going to do is we're going to put primary major in the rows, and then we see that our pivot table is populated with the possible responses to that question. Now, if you don't like this blank option or any of the others, you can remove them by clicking on this drop-down tab, and they will no longer appear in your table. Now, we don't actually have any information at this point, and that's because we have no variables in this summarize values option over here. If I also move primary major there, you'll see that the pivot table automatically counts how many respondents were in each of the major groups. Right. So just to start us off, we could summarize this information by highlighting the pivot table, going to Insert, and we could make either a column chart or a horizontal bar chart to summarize these counts. We'll start with a bar chart. And we can see now we just have a visualization of the table on the left. Now things get more interesting when we add a second variable to this analysis. And to do that, we'll take the variable risk level, which recall was high or low risk, and place it in the columns of our table. We can see now that by doing so, we now have a breakdown within each major of how many high and low risk takers there were, and our chart that we created before also reflects those differences. Now, the only issue with this chart here is that there was a lot more business majors than any other group. And so we can't really directly compare groups here. We might be able to say things like, well, it looks like within natural science majors, there's a lot more, low than high risk takers. And with business, it's roughly even. But really, counts are deceiving when you have unequal group sizes. And it's much better to compare percentages within groups. Now, Excel's pivot tables make it easy to do this. If you click down here on your summarize values, there's an option for valued field settings. So within valued field settings, we can choose to show the value as any number of different types of percentages as well as no calculation, which is what's currently shown. So if, for example, we look at percent of row total, what that's going to do is take each entry in our pivot table and divide it by the corresponding row totals. So if I click on that and hit OK, now we see that the values in our pivot table change as does our graph here, right? Now, the advantage of doing this is now we see this number, for example, right here, means that out of all business majors, 51, almost 52% of them were high-risk takers, whereas with natural science majors, only about 27% of them were high-risk takers. And these numbers are more directly comparable and kind of help us get at the question of which major is more likely to be a high-risk taker. We see that social science had the largest percentage of high-risk takers and natural science had the lowest. Now, if, with humanities, you'll recall there's only 2 students, so this information might not be too meaningful. And you can easily filter a group from the graph using this filter that's available at the bottom here. So if we uncheck mark the box next to humanities and replot the information, we only see the 4 larger groups appearing here. Now, This is probably the best graph to get at if your question is which major is most likely to be a high-risk taker. If we go back to our summarized values as and switch the calculation to percent of column total, we receive a new graph here, and notice that the y-axis values have completely changed. And that's because now all the entries in our pivot table are being divided by the column totals, so that as we sum down a column, it adds up to 100%. This graph is less helpful for answering the question of which major is more likely to be a high-risk taker, because there's so many business majors that it skews the results. So if we look at this graph right here, it looks like business majors, have the highest percentage of high-risk takers, and that's true, but that's just because there's so many of them, right? If we return to our previous graph, we can see that actually, well, with business majors, it was split roughly 50-50 within them, whether they were high or low risk takers, and that's sort of a more meaningful comparison. So choosing the right calculation is extremely important, and it depends critically on exactly which question you want to get at, and that's one of the things you'll be investigating in the first lab.